One of the welcoming development when it comes to LLMs is happening right now in the industry that more and more companies are coming up with smaller models. Deci is one such company which has been releasing smallish models quite frequently. DeciLM 6 billion and DeciLM 6 billion instruction fine-tuned are two of its various models which are really making some serious rounds. DeciLM 6B is a 5.7 billion parameter which is permissively licensed pre-trained LLM using variable grouped query attention or GQA to achieve an optimal balance between performance and computational efficiency. DeciLM6B has been generated using Deci's proprietary neural architecture search technology or AutoNAC. DeciLM6B delivers 15 times the throughput of Llama 2 7B while maintaining comparable quality. DeciLM6B and its fine-tuned variant DeciLM6B Instruct consistently rank among the top performing open source LLMs in the 7 billion parameter category across various LLM evaluation tasks. In this video, I'm going to show you how you can locally install this DeciLM6P Instruct model either on Linux, Windows, or any of the Jupyter notebook, whether it is AWS SageMaker or Google Colab. I will be using AWS SageMaker notebook for this demo, and I am using G4DN XLR instance. Also, let me quickly show you the sizes of this model in terms of GB. So if you go to the model card on Hugging Face and then go to files and version, you will see that it is around 10 GB, I would say. So these are the three files which are massive, rest are very smallish. So this is what we need to download. So in this video, I'm going to show you how you can download it, run it, and then we will be running few tests using different prompts on this model. Okay, so let's get started. My notebook terminal is ready. First thing we need to do is to install the transformers library. So I'm going to do pip install -q transformer so that it installs this transformer in quiet mode. So let's wait for it to finish. Transformers is installed. In the next step, let's specify the model. So I'm importing torch and then I'm specifying the model. And because I'm using G4DN instance, so I have GPU, I will be specifying CUDA here. If you don't have it, then you can simply specify CPU here instead of CUDA. So let's wait for it to finish. That step is done. In the next step, I'm going to use a tokenizer for this model in order to convert it into tokens. So let me run it. Shouldn't take too long. As you can see, it is now downloading the model files depending upon your bandwidth and internet connection. That shouldn't take too long. So as you can see, it is downloading that first 5 gig file and then there are two more big files to go. So let's wait for it to finish. Model download is complete. Took around 10 minutes to download all the files. Now let's give it a prompt to the tokenizer by encoding it and then it will generate the response and then we will print it out. The prompt I'm using here is that how do I renovate my bathroom? Think through it step by step. So let's see what happens here. Let me run it and let's wait for it to come back. And it will also tell us and this response not only depends upon the model itself but also the GPUs and the capacity you are using on your instance. It has returned the results, but they seem totally off. I think I won't really accept that answer. And also, if you are wondering about this warning, this simply means that the model doesn't fit on the GPU provided or barely fits. And we can ignore this warning. If you want to make it disappear, you can simply add something like this in this generate command. And hopefully, in most of the cases, this should get rid of it. Now, let me give it another prompt here. I will just ask it what is the capital of Tonga. Tonga is a Pacific island in near Australia. So let me run it. Again, you can see that it has failed to answer me properly, and that this is a totally off answer. And but you can see that the warning which we were seeing earlier has gone. Anyway, let me try out another prompt. This is again the bathroom one, but I am giving it more detailed instruction to see if it makes difference for it or not. Let me run it. Okay, now this time again really doesn't make any sense to me. Let's try one more example. Let me try out one example from that Hugging Face card, which was used by this the author of this model, which is how do I make French toast. Think through it step by step. Let me run it. Let's see what it does now. Okay. Oops. I don't know what it is saying. Anyway, so we managed to get it installed locally, and we managed to send it through a few prompts. But as you can see, it really failed to answer it us properly. As a one last step, I am just going to give it a coding challenge. Write a Python. Sorry about that. Write a Python code to add two numbers. Let's see what it does this time. Okay, so as you can see, it returned very quickly, but again, the answer is totally off. So I believe that the model is small, but the performance is off. Maybe I'm missing something. If you know what I'm missing, then please share in the comments. But all in all, this is how you install it, and all of these um, installation instructions are on the Hugging Face page, which you can follow up. If you still have any questions or if you face any issues while installing it, let me know and I'll be happy to help. And if you like the content, please consider subscribing to the channel. Thank you very much.